So the first thing we need to do for today's lab is to mix our concrete. And we'll be using a concrete mixer like this one, but a little bit larger. And the first step is to weigh out all of our aggregates, dry them, and then what we'll do is we'll add the aggregates to our mixer. We'll add a certain amount of water to get them up to their SSD condition. And then we'll add our cement and then add the rest of the water and mix it until it's fully mixed. And at that time we can dump it out and our sample is ready to use to fabricate our specimens and run our tests. So what we also need to determine is our water to cement ratio. And for this lab, there'll be 3 groups. So we'll have a water to cement ratio of 0.51, 0.52, and 0.53. And we know that our cement is 20 pounds, so if we multiply our cement weight by our water to cement ratio, we get how much add water we need to add to our mixture. And we're also using a proportions of 1 to 2 to 3, so we'll have 20 pounds of cement, we'll have 40 pounds of fine aggregate, and 60 pounds of coarse aggregate. For the first test this week, we'll be determining the slump of our concrete. So the first step of doing that will be to make our concrete and mix our concrete. And once that's mixed, we're going to take our concrete and we're going to load it into our cone in 3 equal lifts per volume. So our first lift will fill up, and then what we'll do is we'll rod it 25 times. And then we'll put our second lift in, and this time we're going to rod it 1 inch into the other layer. And finally, we're going to add our third lift in and rod it again, penetrating 1 inch into the last layer. And once we're done with that, we'll roll off the concrete. We'll unclip these, and this will be on the ground, and we'll slowly raise this without shearing it for roughly 5 seconds, and our concrete is going to slump. So at that point, we put our cone down, we measure across, and with a ruler or a tape measure, we can then measure the amount of slump from the top down to where it slumps. So the next test we'll be performing this week is the unit weight of our concrete. And for this we'll need our metal container, a strike-off plate, a tamping rod, as well as a rubber mallet. So the first thing that we've determined is going to be the volume of this container, which in our case is 0.25 feet cubed. And the second thing that we need to do is determine the weight of this. So we'll get our scale, set this on the scale, determine the weight, and from there we'll wet down our bowl on the inside. And then what we'll do is we'll take a scoop, and similar to the slump test, we'll fill it up in 3 equal lifts. So we'll put our first lift in, we'll rod it 25 times. Then what we'll do is we'll take our mallet and we'll strike it 10 to 15 times. Then we'll add our second lift. Then we'll penetrate into the first lift by 1 inch. Again, we'll take our mallet, and then finally we'll add in our third lift, and again, going in 1 inch to the previous lift, we'll go around 25 times. And once again, we'll consolidate it. strike off plate. We'll sawing motion, strike everything off. If there's any voids in the surface, we can fill them up just a little bit with some existing concrete, clean off the rim of it, and then we'll reweigh that. So then we'll have our weight of our concrete divided by the volume of our bowl, and that will give us our unit weight. For this next test, we'll be determining the air content of our mixture, and we can take the sample that we previously prepared for our unit weight, and what we'll do is we'll place the top on, secure it. We'll take this, fill it up with water. We'll open up our pepcock valves and inject water in there lightly. You don't want to be blasting it into the sample until water comes out the other side. And we have a calibrated number on here, so we'll pump up to that calibrated number. We'll close our valves off. We'll take our mallet and we'll release the air at the same time as hitting this. And then that'll give us a reading of our entrapped and entrained air in our sample. So the next test we're going to do is we're going to make our concrete cylinders. This will be for next week's testing after we cure them. But we'll take our concrete, and this container is 4 by 8, so the diameter is half of the length, which is a requirement of this test. We'll take our concrete, fill it halfway up. We're only doing 2 lifts in this. Take our rod 25 times. Again, consolidate it. 10 to 15 times. Put our second lift in. Again, penetrate the surface 25 times. Consolidate one more time. And we can roll off any existing. And then we want to let this sit for 24 hours. And at that time, we'll remove it from its casing. And then we'll put it and cure it for, in our case, a week until we test it next. So the final test is to fabricate our beam. And the first thing you need to do is determine the area of it. So we have 21 inches by 6 inches, which is 126 inches squared. And we need to know that dimension because we need to know how many times we need to rod it. And it says for every rod once for every 2 square inches. So 126 divided by 2 is 63. So we need to rod this 63 times per lift, and we need to place it in 2 lifts. So we'll fill up the first half, rod it 63 times. Again, we'll use our mallet. We'll strike it 10 to 15 times. Fill up the second layer again. Rod it 63 times. Consolidate it once more. And then we'll essentially just float the surface and smooth it out. And then again, we'll let it sit for a day. We'll take it out of the mold, and then we'll go and let it cure for the 7 days before our next lab.